Right, hi. Good morning. Hello. Hi there. Hey, hello. Hi. All right, let's go ahead and get started today. So we have a lot of announcements. Bear with us. Here we go. First is go to lab today. There's a lot of useful stuff. We'll be covering more practice on things like control that we'll be talking about today. That'll be really, really helpful for your HOG project, which is coming out soon. More on that later. And in particular, we're going to teach you a little bit about how to pair program. And the way this works in lab as far as submission goes is you just have to submit one assignment to OK for both partners, and you'll both get credit for the assignment. And your TAs in lab will teach you how to pair program and give you like a quick introduction to like why it's important to learn how to communicate with others. In addition, make sure to go to Get Discussion tomorrow, particularly because we'll be having our first discussion quiz. It's a great way to get feedback on how well you're doing on a concept. And this discussion quiz is going to cover material up to yesterday's lecture. In addition, discussion is great because TAs have many tips and tricks to share. They're also pretty nice people. So go ahead and get to know your TA. Homework 0, the survey is due Friday. Homework 1 has been released. It's going to be due Sunday. And the HOG project will also be released tonight. It's going to be due next Thursday. And in particular, the first half of the content can be completed with today's lecture. So I really want to recommend you to get a head start, try to finish this before, like maybe over the weekend while you have a little bit of time, because some of the second half relies on Monday's lecture. So if you can get through maybe like the first half up to like question 5, the play function, that'd be pretty great. Get a good head start. In addition, the class potluck is this Friday, 5 to 6:30 p.m. A couple more announcements. Group mentoring sections are for the entire hour. So even though you might have only signed up for like a 15-minute slot, that's just because of how we place in the system. You actually want to attend for the full hour. And I heard from the TAs discussions are pretty wild. Yeah, quick question.
About the class club,
Yeah.
to bring food, like how much are we bringing?
How much food to bring to the class potluck? As much as you can. I guess for like a more reasonable amount, maybe, we have like a pretty large, like a tray, if you could, like maybe like a medium size or a large size tray, depending on how much you feel comfortable making. Yeah, that'd be great. Yeah, so I heard from the TAs, the discussions were pretty wild yesterday. And just from our experience, it tends to get like a little less crowded over the next few weeks. So if you just hang in there, keep on attending discussion, people will figure out, okay, maybe I should go to like a different discussion or whatnot. So it'll eventually thin out a little bit and then it'll become a little bit more palatable. Evening and next day morning sections in particular are a little bit less crowded. So if you have a flexible schedule, you might as well try out an evening section. And going off of some feedback from yesterday's lecture as well, we're going to try a new system for handling questions so it doesn't get kind of out of hand. In particular, we're going to try a new Piazza live thread Q&A. So if you have any like quick questions you want to get answered, our TAs over here will be answering them online right now. So you can go ahead and even like say hi to them on Piazza or something. In addition, I think Stan is going to be running around and answering like any like more complex or conceptual questions as well. So you have two options. You could either ask Stan or you could post on the Piazza live thread if it's just something like a quick answer, maybe within like a couple sentences. And for people who want to participate in lecture for lecture questions, this is the fun part. You can stand and shout your name and then your question. That way we can all get to know you. It'll be fun, trust me. Just get really into it, just like how I am, you know? if you are enrolled, quick note on enrollment. If you are enrolled, please do not switch sections on Cal Central. I've heard like some horror stories about people trying to switch sections and then they get waitlisted. So if you're already enrolled, please don't change your section on Cal Central. But if you are on the wait list and there happens to be an open space in lecture, lab, and discussion, my recommendation is to actually drop from the wait list and then re-add into the course into those open sections. There's no way to actually switch sections from the wait list, so you have to drop from it and then re-add. Okay, cool. Now onto actual course content. We're going to start off with like a little bit of review from last lecture. We're going to cover some return, print, and none. So I mentioned none earlier is representing that nothing is returned. And if we take a look at Python, here's a couple examples. So we've already seen before that the interpreter can evaluate expressions like -2, and it'll tell me that when I type in -2 with characters, it'll tell me that it evaluates the number -2. And the print statement kind of looks like the same, right? I can say print -2 and it'll give me more or less the same looking output. If I say go Bears, Python will evaluate the string, right? It'll evaluate, it knows that when I say quotes, it means a string. So it'll say I have a string. But if I try printing go Bears, the output's actually slightly different. Do you notice that there's like no quotes around the go Bears? So that means like in some ways, print is fundamentally different from how Python evaluates stuff normally. So our goal is to figure out how is it different. So let's just try a couple more examples too. I can print multiple arguments at the same time. Print 1, 2, 3 separated by commas. The output will be 1, 2, 3 separated by spaces. And remember that when I ask Python, the interpreter, to evaluate none, it doesn't show anything. So it's like the special quirk about the Python interpreter is when you ask it to evaluate none, it doesn't show it. But interestingly, if I try to print none, Python will show it. Python will show it when you try to print none. We've also seen some assignment statements. We can set x to be -2. And now if I ask for what x evaluates to, I should get -2. Now if I try to do the same thing with x equals print -2, what Python will do is it'll evaluate this call expression on the right side, which will say print -2, and then it'll assign the return value of the print function, which is none, back to x. So you'll see, before we even asked for the value of x, we went ahead and evaluated that, right? Which told it to print right now, before doing anything else. So it printed the -2, and then now x is bound to none. So now if I try to ask for x, I shouldn't see anything because x is none. So that's like a quick introduction to Python's behavior. Now, for the technical definition, none is a special value that represents nothing in Python. So it's a value just like numbers are values, or just like strings are values, and so forth. And functions that do not explicitly return a value will return none. And none, as we noticed before, is not displayed when evaluated by the interpreter. So as an example, when I define this function does not return square of x, notice that there's no return statement. So when I actually try to run this program, it'll compute 4 times 4, for example. But then it'll immediately throw it away because I'm not returning it, I'm not using it anywhere. So it throws it away and returns none back outside. So since we know this returns none, we shouldn't see anything on the next line. So if I try to run some different command, does not return square of 4 again, we know that it returns none back to the outside environment. So what I'll get is 16 is bound to none. So now if I try to compute 16 plus 4, it's like saying none plus 4. And because none is like a special value, the special property being that it can't be combined with any other types of values, we'll get a type error because we can't add nuns and numbers. Yeah, question. Stand up and speak your name.
And it's in, if you were to just evaluate 16,
Thank you, Ethan.
if you were to just evaluate 16, would it just come back as nothing? Or would it actually print nothing? Or would it evaluate as nothing?
Great question. So if I just type 16 into the interpreter right now,
Yeah.
yeah, so if I just type 16 into the interpreter right now, we know 16 is bound to none, right? And it's like essentially the same as typing none into the interpreter. And that just doesn't show anything. Great question. Thank you, Ethan. Okay. So this is a new slide. What's the difference between print and return? So I wanted to focus on this in particular because I think we haven't talked enough about return. So printing, as we learned in last lecture, is just a side effect. And so in particular, the big implication of that is that it is not a value that can be used by Python. We saw that you can't add none and for, right? Whereas return statements allow us to pass values between functions. It's how I share information. Like for example, last lecture we defined a function that actually squares numbers, right? Like I could say square of -2 gives me 4. The way I can compute that 4, the way I can receive that information back from square is using the return statement. So I can, for example, define a function favorite who will return my favorite person. His name is Stanfield Chu. My love, of course, is my favorite. So if I ask for what my love is, I should see Stanfield Chu. Now, I can combine the string I love and my love to give me I love Stanfield Chu. So this only works because the return value of favorite is a string, right? It's not none, it's a string. So it's something I can work with. I can add, like for example, hello plus world, the same way I can add I love and another string. Now, however, if I try to print instead of returning, what I should see is kind of like before in the interpreter. When I tried to say x equals print of -2, I'll see Stanfield Chu right now. And then none is returned back to my love. So my love is none, unfortunately. So when I try to say I love plus none, then I'll get an error, which is to say that I can't combine a string with none. So this is like the big implication of this, of printing. Yeah, question. Stand up and name. Hi.
And what's the difference between double quotes and single quotes? And then also, if you do the triple quote inside of the print, does that mean that you return a string?
Great question. So Arda, right? So Arda asked, what's the difference between single quotes and double quotes first? So single quotes and double quotes are both ways of representing strings to Python. So you can use either one as long as you're consistent. So here you can use single quotes, or you can use double quotes, and they'll both mean strings to Python. So strings are just like sequences of characters that represents like maybe like words or anything else you want to say. And the other question was, what's the purpose of like the triple quotes? How does that work? The triple quotes is just like another way of giving you a string. The way we use it in like functions is we might say def favorite, and then I might say triple quote, this function returns my favorite person, and triple quote. And that just gives us some information about this function. You don't have to worry too much about that syntax, but it's just a string. Okay. So we learned that pure functions just return values, and non-pure functions have side effects. So for example, pow, which is a function that raises numbers to some power, is a pure function because I can give it 2 and 27, and it'll give me a really big number as an output. Non-pure functions like print have a special behavior because when I pass in 2 arguments, for example, I'll get none as the output, as the return value. I'll get none as the return value, which is usually not displayed by the interpreter, right? Because the interpreter doesn't display none. But Python, along the way, will display the value will display the output 2 and 27. So this side effect isn't something that you can use again. So these the printed values are not things you can use in Python. So if we look at the nested expression example again with print and print1 and print2, we know that the output looks like that. We have 1 on a line, 2 on a line, none, none on the last line. So if I go through the evaluation procedure, which tells me to first do the operator, then the operands. Operator is print, we know it's a print function. Then the first operand is a call expression. So we have to evaluate it. And the way that works is I say I pass in 1 for the argument, I return none, but along the way I print that first 1 on its own line. Now that I finished the first print, I can go to the print2, which also creates a new print function like that. I pass in 2, I get none as the return value, but 2 gets printed along the way. So the important part to remember here is when I'm trying to evaluate the entire call expression, I figured out that print of 1 gives me none, and print of 2 returns none as well. So now it's like saying print of none and none. So to see that visually, I'll have print of none and none, and that's where these two nones come from the first one and the second one. And so if I try to print none, none, I'll return none, which isn't displayed, but along the way, I'll have printed none and none. So that's where that last none, none comes from. Any questions about this slide or anything we've covered so far? Yeah. Do you want to stand up and?
My name is Jay, and it's a really basic question, but so are the values, like the integers, always first? So it's 1, 2, none, none, or can it be like none, none, 1, 2, ever?
Great question. So Jay's question is, does the order of the output change, or could it be different? And so this is actually a really, really important point. So on the exam, for example, the order of this output is super important. Like it's probably the most important part of this entire problem. So the order of this output represents the order in which the functions are evaluated, right? Because the only reason why I print 1 before I print 2 is because we evaluated the print 1 call before we evaluated the print 2 call. So the order of that output tells us something about the way the functions, or the order in which the functions are evaluated. And that's kind of what we're interested in this part of the course, figuring out how things are evaluated, the order they're evaluated in. That's like a useful tip for tomorrow's quiz as well. Remember that the order of evaluation matters. Yeah.
I'm Howard. I really stand up.
Okay.
Why are they on different lines?
Yeah, so Howard's question is, why are they on different lines? I think that's my fault. I forgot to mention that after you print, a single print call makes, for example, 1 line of content, and then it breaks and gives you like a new line after that.
Okay.
Yeah, so after a single print call, you get a new line.
Okay.
Great question, Howard. Yeah, Ethan, go for it.
Is that only when printing something? Does it get another way? Or what are the cases that like returning value would go to the next line?
So in this case, the reason why so Ethan's question was, is printing the only scenario where we go to a new line? In printing, that is, I think it's mainly something to do with the way that we show the output. It's because this output is part of something that isn't Python's main process. Because Python, for example, we do this evaluation procedure where we share the results with someone else, right? And so that result is like kind of like pipelined. It's going through to some other function, right? And someone else is going to use that data. So, but in the case of the printing the output, it's like doing something completely separate from Python. So I don't really think, in short, I don't know the answer to your question, basically. But I think in this case, we just create a print for that, but I'm not sure if there's some edge case or something I don't know about Python that might also do something similar where it creates a new line. But you can just try around in the interpreter, try printing some stuff, try evaluating some stuff, and it should give you some intuition for like when you create new lines or when you don't. But usually when you print, you make a new line just for that printed stuff, and then you can go do something else. All right. Cool. So here's an application of print and return and why you might want to use them. So remember that the operands of a call expression can be any expression. And in fact, this includes expressions that evaluate to functions, such as function names themselves. So as an example, if we look at this, I've defined a square function. I've defined a function describe. And in the body of the function describe, what it does is it prints a little bit of useful information. It's going to tell me I called the function with this argument x. Then I actually try to call it. And at the very end, I print the result was this result. So what I'm doing here is I'm going to tell myself a little bit more about what I just did, essentially. So the idea should be, if I try to run this a little bit, I'll define square, define describe, and now when I try to compute describe square of -2, what I'll get is I'll go in the body, and the body tells me, let's go to our print statement, and it says, we're going to call the function with argument x. So this is telling me some information right now. This is a process that's called debugging. So it's useful to add print statements if you want to learn more about how your function or your program is working. So I can see that I'm calling the function with argument -2. Then I actually call it, which goes into the square function, returns and computes 4. At the very end, I'm going to print to say to myself, the result was 4. And then I actually return the result back outside. And then that result is assigned to the name 4. So the reason why we care about this is because sometimes when you're working on the project, for example, Hog, you might not have the Python tutor to help you out and help you understand what's going on. A really good trick to use is to add print statements into your code to figure out what is going on, what are my names assigned to right now, and just to understand more about how your program is working. So this is a useful trick for projects in particular. Okay. So here's the code again. As an example, I'm going to, when I do that same call, I get these 2 lines. It tells me that I called the function with this argument and that what the result was. And same way with this. I can also describe, sometimes like the values are hidden, right? Sometimes you don't know what the name 4 is bound to. So it's useful to add this statement because I can tell what was passed in and what I got out. Because sometimes it's not clear from the names that I'm passing in what exactly they are. I could have named this like 5, and if it was actually 4, this would tell me a lot about where my program was going wrong. Okay, now we're going to move on to control. And so control, so far we've covered expressions, which expressions are defined as expressions in programs evaluate to functions. Statements are executed to perform actions, and we've learned 2 types of statements so far. We've learned assignment and def statements, but it's kind of hard to build complex or powerful programs just with assignment and def statements. For example, how would you write a function that computes the absolute value of a number, or if you want to figure out which one is the max of these 2 numbers? So there's a way. We're going to introduce an idea called control. And what control is defined as is we have these special expressions and statements that can control the way the program is executing, like the order in which we do stuff, where we go next. So we're going to talk about conditional statements first, and we have a quick demo. Clear this a little bit. So I have Python 3. And I'm going to define a function to solve that absolute value problem. So if we define a function called absolute value of x, what I can do is in the body, I can say if x is less than 0, I should return -x, because I want to get the positive version of it. Else if or in Python we say elif, but it really means else if. Otherwise, if it's the case that x is 0, what I can do is I can return 0, because I know the absolute value of 0 is 0. And in the last case, I can say else, or otherwise, if it's not either of the two. So if it doesn't fall into any of the cases we saw before, what we can do is we can return x itself, because we know if it's not less than 0, we know if it's not 0, then it has to be greater than 0. So we return x. And so we define an absolute value function that can say absolute value of -2 gives us +2, absolute value of 4 gives us 4, absolute value of 0 gives us 0 as we'd expect. But this was kind of like a lame activity because we already have a built-in function that does that. But I just wanted to show you like a tool for this is how we can use control to build programs that have interesting behaviors that aren't just like squaring, for example. Okay. So here's like a simplified version of that code. We can say define a function called absolute value that takes in an argument x. If x is less than 0, return -x like we saw earlier. And for simplicity, we could just break down the else case into just return x. Because if it's not less than 0, let's think about the cases what if, for example, x is 0, then we just return 0 itself. So it's like a simplification of the cases. And the thing to notice about like all this material we've covered so far is that we have a couple rules for how this works. The syntax says we always start with the if clause. So the if at the second line over there. Then we proceed into 0 or more elif cases. For example, the code I showed in the interpreter had one elif case. And then we can have 0 or 1 else clause. So it's optional if you want an else clause, but you can have at most 1. So to show you how this works, each header is considered in order. Like for example, when I was executing absolute value of -2, I passed in -2 and then went line by line through each header's expression, checking which one was true. So I evaluate the header's expression if the header is not an else. And if the expression is a true value or the header is an else, execute the suite and skip the remaining headers. So what that means is, for example, if my number is -2, I'm trying to find the absolute value of -2. What I'll do is I'll go to the first header, which says, if x is less than 0, I see that that is true for -2, right? If -2 is less than 0, which is true, I'm going to use this return line and return +2. And at that point, we're done with this program. So we only consider up to the first clause that is true. So just to highlight the parts again, we have headers over here, and then we have each suite, which is what you do in the case that that header is true. So notice that the suites are indented, kind of like the way we do it with def statements as well. So you indent them with a couple of spaces. Okay. So let's talk about Boolean context as well. So this is a man called George Boole. He's a famous logician from quite a while ago. He's one of the persons who's made a lot of contributions to computer science. So since he's pretty important, let's make him pretty big. Here's our absolute value function again. So we've seen this a couple of times. But the important part I want to point out now is this idea of Boolean context. We've learned before on the last slide that we evaluate each header in each clause, right? I just want to give you a new definition to work with. What do we actually do to evaluate that header? So we have this thing called a Boolean context. And a Boolean context is any place where an expression is evaluated to check if it is a true value or a false value. So there's something that's really subtle about this, true value or false value. Notice that this term is true value. I'm not saying it's just true. Because when I actually evaluate something like this, x is less than 0, that Boolean context will give me, if for example x is -2, for example, if x is -2, for example, when I evaluate that Boolean context on the second line, what I'll get is true, which happens to fall under the category for true values in Python. But there are other cases for things that might be false values that aren't necessarily just plain false. For example, none that we talked about earlier is also considered a false value. I could say 0 and that's a false value. So for example, if my Boolean context was, instead of this line, I could say if 0 or if none. That would result in a false value. That's the distinction I want to make. False value versus false. They're not entirely equivalent. Okay. So are there any questions about the material we've covered so far? Yeah, go for it.
So when it says by value, does it mean it's like returned like other data?
When it says by value,
When it says that like gives a true value,
Mhm.
gives out a true value, does it mean it's like returning information?
oh, so, okay, so for the Boolean context,
Yeah.
for the Boolean context, what does it mean to say true value? Where does that come from? So the true value, you evaluate this Boolean context. You evaluate this Boolean expression. So what you'll get is when I check if x, for example, if x is like 4, in this case, if x is 4, I'm asking, is 4 less than 0? That's not true. So that would result in the value false, which falls under the category of false values. So we go through this process of evaluating each expression here in each Boolean context until we find a valid header. Does that address your question? Okay. So let's talk about Boolean expressions, which I hinted at a little bit earlier. Boolean expressions contain special operators like and, or, and not. So the format for and looks like this. I could say some expression and some other expression evaluates to true if both expressions are true. So intuitively, it's like saying, I need to have both of these things be true in an and for the entire Boolean expression to be true. Likewise, we can define or as evaluating the true if at least one of those expressions is true. The special keyword not evaluates the true if the expression is a false value. So for example, not only false, but none, 0, empty string, stuff like that. And it evaluates the false if the expression is a true value or anything else. So notice that it takes like some false value and turns it into the actual true. It takes some true value, which can be a lot of different things, and turns it into actual false. So there's some special short-circuiting behavior involved with this code. I have two expressions. Let's call them left and right this time. If I have those two expressions and it does what the and code will do is it doesn't evaluate the right if the left evaluates to a false value. So if I already know that the left expression evaluates to a false value, why do I have to keep on going? Right? Because if I know my rule is to say I need to have both of them be true, if I already know the first one is false, then I can just say this entire thing is false. So the idea behind short-circuiting is trying to figure out, like, are there any ways I can finish a little bit early? Because I already know one thing is false. Likewise, we can define or the same way. Or does not evaluate the right expression if the left expression evaluates to a true value. So since or is saying, I want to find the first true value, so since it's the left, since I already know the left expression is true, I have no need to keep on going. So as an example, I can say 0 and 1 divided by 0. Alert, 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 right? 1 divided by 0 is a 0 division error. So if I actually evaluated this, my Python interpreter would get really, really mad at me. But because of the short-circuiting rule, which says 0 here is a false value, it won't go here. It won't try to figure that out. Likewise, if I do or though, or says I want to try to find the first true value, essentially. But since 0 is a false value, I say I haven't found my true value yet. So I have to keep on going to the next expression. But the next expression gives me a 0 division error. Questions about this short-circuiting behavior? Because it's pretty tricky. quick demo coming up. All right, let's go back to the interpreter. So let's restart a new Python interpreter session. And this time we'll explore like a couple more of those Boolean expressions. So for example, I could say 1 gives me the number 1. And that's considered a true value, right? But when I do the rule for not 1, I get false because I said 1 is a true value and not changes it into a false, an actual false. Same way with 0. Since we know 0 is a false value, we should get, oops, my bad. If it's 0, then we know we should get true because 0 is a false value. I can combine false and true. So if I try to evaluate this, remember false is trying to find, it wants to make sure that both of them are true, right? So if I already know the first one is false, I should get false and not even bother looking at the second true. I could do true or false, and the same short-circuiting behavior happens. I see the true and I'm done. Now if I try to do 1 divided by 0, I know that 1 divided by 0 gives me a 0 division error. But if I do the thing for the short-circuiting rule for 0 and 1 divided by 0, I'll know 0 is already a false value, right? 0 is already a false value, so there's no need to keep on processing, no need to keep on trying the other things. So I'll just get 0 straight out. Notice here that I actually returned 0. I didn't return false. What the AND does is it'll say, I'll return that last value that I evaluated. So since this one evaluated to a false value, I'll just go ahead and return that false value. Notice that I did not return false. I didn't return actual false. And if we try the same thing with 0 or 1 divided by 0, like we saw on the slide, it'll give us that 0 division error because it went through and tried to evaluate it. I can keep on doing one more example, 1 and 2 and 3 and high. I can combine these in like a chain. And what it'll do is it'll go left to right and try to evaluate, make sure all these parts are true. So I'll say 1 is a true value, 2 is a true value, 3 is a true value, and high is not the empty string. So since it's not the empty string, it is a true value. So when I try to evaluate this, I'll kind of go back to this example, and it'll give me the last value that it looked at, which is high, which is a true value. So OR works the same way too. Does anyone want to try something? Yeah, Arda, go for it. Shout.
If you have an and and or, which has priority?
And an or. So we'll learn a little bit, you'll get a lot of practice with that in lab. So the way and or works is, let's try an example here. Let's say I have 1 and, how about I give you the rule first? So the way the rule works is, or is like you're separating two parts, right? Or has two expressions. Or is less sticky than and. You can think about it that way. If you have like a visual for magnetics, and is like more sticky than or. So like it'll try to group using the ands first, and if it can't group using the ands, then it'll look at the ors next. So it'll try to group with the ands and then try to group with the ors. I'm sorry I don't have a great answer. I'm not really prepared to give you an example right off the top of my head, but you'll have more practice with that in lab today. Is that okay? Yeah, I just don't want to like mess up and like give you a bad example. Yeah. Okay. So back to the slides. If I move on, today we're gonna have a break. Break time. We'll be walking around and you can ask those questions as well. Let me come up with an example right now. Yeah. Hi, what's up?
You did 1 and 2 and 3 and high. Why didn't it give us true instead of? Why didn't it give us true? It gives us
Great question. So remember that it's just going to a true value, not actual truth. So it wants to make sure they're all true, right? They're all true values. So it doesn't goes through each of the terms. Right? That's okay. Yeah. So it goes to the last term. And what it does is instead of changing that to actual true, it just returns that last true value. It's just how it works. Yeah.
So instead, if I have like 1 and 2, it would just return 2 just as well.
Yeah, exactly.
My name's John. So, what for the Boolean context? What does the double equal sign means?
What's a double equal sign means? Oh, it means that it's asking, is this equal to that?
Oh, so
Yeah.
so what if you put just 1 equal sign there? What's
Sorry?
the difference? What if you just put 1 equal sign there? What's the difference? Like,
Yeah, so one equal sign is, do you remember assignment statements?
Yeah.
They use one equal sign.
yeah.
So when you use one equal sign, it's like you're trying to say, I want to assign this to be that value.
Okay.
But 2 equals means I want to check, are they the same
Oh,
value?
that's the testing.
It's testing, yeah. So it's checking versus assigning.
Okay, so that.
Yeah.
Okay, I gotcha.
Does that make sense?
Yeah.
Okay. Okay, I found a good example for Arda's question. Let me give it a shot. Let's see. I'm gonna start. Oh, yeah. All right. So I found a good example to Arda's question. And Arda's question again, he was asking for what's the priority for and or. So for example, which one has higher priority? Which one is like more sticky? Because if I have like a bunch of ands and ors, how do I know which one goes first? Hi, hey, hi. Hey, hi, what's up, guys? Okay, yeah, so Arda's question was, if I have multiple ands and ors together, how do I know which one goes first? So as an exercise, how about we try this? True and not false, or not true and false. So spend a moment, try to think about what you think this will evaluate to. So I said the rule earlier was or is less sticky than and. So like we'll try to do ands first. Spend another 10 seconds. All right, now that you have like a thought, go ahead and turn to the person next to you and talk about what you think. Shout it into their ears. All right, let's come back together. Hi, y'all. Hello. Hi, I got you. Hey, hi. All right, so thank you for the discussion. So let's go ahead and evaluate that. What's the answer? True. So Stan just mentioned to me a really cool metaphor that he uses, which is to try to relate this to mathematical operators. So if I think about arithmetic, I might think of and as being like multiplication, if you know how the multiplication symbol works. I might think of or like the plus sign, addition. And then maybe not is like negative, negation. So in this case, it would be like multiplying, which is tighter grouping, which groups more tightly than adding. And here's another multiplication, which groups more tightly than the adding. And this negation groups tighter than the multiplication. So I think of negation as like a single number rather than subtract. So if you think of negation as like a single number, then this is like the tightest. Then the multiplication comes next, and then the addition as a whole. So if we try to evaluate that, then this is essentially equivalent to saying true and not false, or not true and false. So once you put in those parentheses, it helps give you like a visual sense for what's actually going on. And I actually recommend if you're writing real code, it's better to put in the parentheses and like not have to worry about things. It makes it really clear to someone else or even yourself when you're reading the code what you mean. Yeah, question.
So it's not possible for like one like not true to be part of an or and an and at the same time.
Oh yeah, good question. So what was your name?
Mustafa.
Yeah, Mustafa asked, is it possible for a not true, for example, to be part of an and an or at the same time? And that is correct. So it can't be part of like both things, if that makes sense. Because we evaluate essentially, we evaluate true, and then we completely evaluate not false. And then we completely evaluate the and. And then that entire expression is going to be part of this or. And the second part of the or tells us to do the same thing on the other side. Yeah. Howard,
so
go ahead.
For this question, like the second part doesn't matter, right? Because after the first part, if it's true, then it's true.
Yeah, exactly. So Howard pointed out something about the short-circuiting behavior for this question, which says, since I have an and here, I'm trying to make sure both of them are true values, right? So I know this one's true, And this one also returns true to me. So I have true and true, which is true overall. So this entire first part is true. And then if I try to plug that into an OR, I know OR wants to just find any one true value. So I already have one true value and I'm done. All good? All good? Hi. Hello. Hi. All right, let's move on. Okay, break's over. Let's talk about iteration, our second topic for today. And so, iteration, there are going to be two different structures we'll be introducing today for iteration. The first one is called the while loop. And the while loop looks like this. I have some code here to define a factorial function that takes in one number n. And what the factorial does is return the factorial of n. So let's say I'm asking for the factorial of 5. The factorial of 5 is equal to 1 times 2 times 3 times 4 times 5. So what this code will do then is what it'll do is it'll set up two names, I and total. And so I is going to count how many things I've done so far, how many of those 1, 2, 3, 4, 5s I've done so far. And the total will keep track of my value that I've been accumulating as I go through that sequence. And so what the while loop tells us is while I'm not done yet, essentially, while my I is less than n, while I still have more work to do, I'll increment my I plus equals 1 is just like I equals I plus 1. So I'm going to increment I, add 1 to I. And then I'm going to multiply, take the product of total and I, and reassign that to total. So this is like total equals total times I. So this will count from 1 to 5. I's will go from 1 to 5. And total will go from 1 to 2 to 3, 1 to 2 to 6 to 24 to 120. And so at the very end, we'll return that 120, which computes the factorial of 5. So to give you the rules again, the way it works is we first evaluate the header's expression. And then if it's a true value, execute the sweep and return to step 1. So the expression, the header's expression that we're concerned with is that little Boolean expression over there, I less than n. We want to check if that's true. And if it's true, we go inside the body or the suite, and we keep on evaluating inside. So we execute the suite, and then once we finish the suite, we go back to the while condition and check again. So if we pull up a quick demo of that, have it ready right here. And so if we look at the code here, I've defined the function factorial, and I'm about to execute factorial of 5. So what I'll do when I call this function is I'll make a new local frame that's called factorial, because we got that information from here, and it takes in an n, a formal parameter called n, which we assign to the argument 5. So then when I try to execute the function, what I'll do is I'll create 2 new bindings for I and total, each bound to 1. So I equals 1 and total equals 1. And then here's the while loop part. So what I'm going to be doing is I'm going to be going from, I'm going to consider whether my I is less than n. So 1 is less than 5. That's a true value, right? So I'm going to say true and go inside. I'm going to increment I. So I is going to be 2 now. Oops, did I miss? Ooh, let's go back. So I is going to be 2. And then I'm going to multiply with total. Take the product of total. Yeah, multiply with total to give me 1 again. And then now that let me step back. My bad. Got messed up. So if we start from the top, I is 1, total is 1. With me so far? Now I is indeed less than n, right? 1 is less than 5. So what I'll do is I'll multiply, I'm going to increment I to be 2, and now I'm going to multiply that 2 to total. And now total is 2. And then after that, I loop back up to the while loop. I check if 2 is less than 5, which is still true. What I'm going to do is I'm going to increment I again to 3. So now I is 3. I'm going to multiply 3 times 2 equals 6 and reassign that to total. So now I check again. I is still less than 5, and I continue the process. I increment I to 4. I get 24 as my new total. Check again, still true. Increment I to be 5. Multiply 5 times 24, 120. And then at this point, now I'm going to check I is less than n. 5 is not strictly less than 5. So that means this is no longer true, and I'll exit the loop. And notice where I exited. I exited down to below the body of the suite. And then the next line tells me to return the total, which is 120, which is our final value, and we complete the execution of this program. Does anyone want me to replay some part of this? Yeah. So thank you, Joanne. So if I switch the 2 lines between I equals 1 and total. Oh, if I switch these 2, let's see what happens actually. Nice thing about Python tutors, you can actually change stuff. So if we just flip the lines around, we might get a different result, right? Let's see what happens. So I've defined my factorial, calling factorial, setting I in total be 1. I'm true, so I'm going to go inside. But now this first iteration, I'm going to multiply it by 1, right? So 1 times 1 is still going to be 1. So now I'm going to increment I to be 2. That's still true. It's going to be 2. It's going to give me 6. Then 24. But now when I try to evaluate I less than n, right? Is I less than n now? It's not strictly less than, because 5 is not less than 5. So I exit and I return early. Yeah?
Would it return the same thing as it originally did if you changed the less than to less than or equal to?
Yeah, great question. What was your name?
Adam.
Yeah, Adam mentioned that maybe if I change the condition now, maybe if I made it less than equal to. So this is like a new symbol we can learn right now. If I made them less than or equal to. So before, when I just had less than, that meant strictly less than. It has to be strictly less than n. But now if I make it less than or equal to, now it will go up to and including 5. So if I skip ahead to the useful part, notice here that when I check I is less than or equal to n, it is true, so I go inside the body and I compute the correct result. But I does end up getting incremented to 6. So that's like an interesting side effect of this choice. Ethan, go ahead. Thanks. Yeah, 5 and 6. Yeah, so it's like a little bit of syntax. Let me give you the equivalent code. Maybe this will make it clear. Let's say, so this times equals symbol is the same as, or for our purposes, it's the same as total equals total times I. And the same goes with plus equals. Plus equals is the same as I plus 1. So it's just performing an assignment at the same time as the computation. Great question. All right. Cool. We'll have a little more practice with that later in lab as well. All right. So now we'll learn a little bit about sequences. So we learned about counters and I in the while loop, right? So here's a new structure called the for loop. We have a function called factorial again, but it's defined a little bit differently. Here we only keep track of the total, and instead, inside of the for loop, we use this counting name called I. So the execution rule for the for loop, for the for statement, works the same way as a while loop. I evaluate the sequence in the header's expression, and then for each value in the sequence, in order, I will go through and bind that I to each value of that range. So here I'm going to go through and bind the name I, to each value in the range of the sequence. And then after that, I will then execute the suite itself. And I'll keep on doing that looping behavior, where I will go from 1, 2, 3, 4, and 5. So the sequence that we're going to evaluate is the range. So we evaluate the sequence up front. And then for each value in the sequence, what I'll do is I'll bind I to that value in the sequence. So the range sequence gives me 1, 2, 3, 4, 5. You kind of think of that as like a list. 1, 2, 3, 4, 5. And what we'll be doing in each loop is we'll say I set I to be equal to 1. Then set I to be equal to 2, and so forth. And then for each of those i's, we'll execute the suite as well. So I'll set I to be 1, run the suite. Set I to be 2, run the suite. Set I to be 3, run the suite. So as an example, here's what it looks like in Python Tutor. I've defined the factorial function. When I try to call factorial with the argument 5, pass it into n, and now I'll set total to be 1. And then for each I in the range of 1 to n minus 1. So here's the subtle part. I'm going to go ahead and evaluate the sequence first. So I'll figure out what does my range give me. And then only after that will I start assigning to I. So it's kind of like, I think it's going to be 2 steps in one. So the Python Tutor doesn't show you this, but we evaluated this range, which gave us 1, 2, 3, 4, 5, like a list up front. And then we set I to be the first value in that list, 1. So that's why I is 1 over here. Then we multiply, take the product of total and I. So I'll still keep it at 1. And now that we've gone to the header again, what I'll do is I'll set I to be 2, the next value in that list. I'll set I to be 2, take the product with the total, set I to be 3, take the product with the total, and so forth until I compute my final result. Notice here that the sequence ends at 5. So it goes 1, 2, 3, 4, 5, even though I defined the endpoint of this range to be n plus 1. So it's like saying range from 1 to 6 gives me the numbers 1, 2, 3, 4, 5. So it doesn't include the endpoint. So it's exclusive on the last number. And so that gives us the return value of 120, which works more or less the same way as we expected from earlier. Okay. So again, the important thing to realize is that the way we define this range function is we tell it, here's where you start. You start at 1. And then you go all the way, but not up to n plus 1, for example. So it'll go from 1, 2, 3, 4, 5, but not 6, even if I put 6 here. So it's exclusive on the endpoint. So the reason why we do this is because it's useful to sometimes have like 1, 2, 3, 4, 5 that has 5 elements. So you can easily create ranges that have the number of elements you desire. Because 6 minus 1 is 5. Okay, so just a quick summary of today's lecture material. We first talked about control, which allows the interpreter to be selective in terms of what it wants to execute. We can give it some extra behavior, like, for example, figuring out the absolute value of a number or so forth, or the max of 2 numbers. We also learned about conditionals, which is how we implement control statements. This is how we get that different behavior. We have to have, on some condition, we have to choose this over this. We have to have some reason or some reason to choose this clause over this clause. And then using this, we wrote an absolute value function. We also learned about iteration just now, which allows parts of our programs to be repeatedly executed and do other interesting things like computing the factorial, just like we learned. Okay, any questions? Yeah, back there. Go for it.
For the range, can the range be changed during the body of execution?
Oh, great question. Let's go back to the range. Yeah. So what was your name again?
Martin.
Yeah, Martin asked about the range. Can the range change during the execution of the for loop? It's a good question. But based on this rule, it says at the very, very first, we execute the sequence. We compute the sequence, and we remember that sequence. So since we'll be computing the sequence up front, if you have a sequence like a range, it can't be changed later on. But we might learn some techniques that allow you to change things during the runtime of a program. I think this will be important during your ANTS project, but that's halfway through the course. So there are ways to cause problems with this, but for now, we don't have to worry about that. Yeah. Jay, did you have a question?
What is the difference between iteration and loops?
Oh.
it seems the same.
Yeah, so Jay's question, what's the difference between iteration and loops? I think if you're using it casually, you might mean the same thing. There might be like some subtle distinctions in the sense that loops might refer to, there might be like some subtle connotation in terms of like what you might mean. Like loops might refer to the actual looping behavior, whereas iteration, I guess, refers to the same thing. Yeah, I haven't thought too much about that, but maybe we can talk about that afterwards as well. I think for the most part, we'll can use them like mainly interchangeably, but if I change my opinion, I'll definitely let you all know. Cool, any other questions? About anything we covered so far? Martin, go ahead.
Is there any other sequence that
Yeah, so there are actually plenty of, so Martin's question was, are there any other sequences than ranges? And there are plenty of other sequences like lists and tuples that we'll be learning later as well. Yeah. Okay, so otherwise we went through the summary and I think we're almost done. So using this, we wrote a factorial function. And that's it for today. Thank you so much for coming to lecture. Tomorrow Stan will be teaching, so you can finally get rid of me. I'm so tired.
Can I ask you a quick question?
Sure.
So in C++, usually we do the I is 0 instead of 1. Is it the way it is in Python? That the I starts with 1 and the range starts with 1 instead of 0? Like since the counter in C++ starts with 0, but in Python, does it start with 1 necessarily, or can it start with 0?
Yeah, you can set your start to be 0,
Okay.
or if you don't include a start at all.
Okay.
So if you only have one argument, it'll just say, it'll go from like, it'll assume you start from 0. So the same behavior as C.
Okay.
Yeah.
I see. Thanks.
So you can either set the range to start at 0 or don't include that argument.
So what does the range actually mean? Like range itself, does it mean that all the numbers from 1 up till n?
All the integers, yeah.
Okay.
Yeah, so there's increment from 1, increment by 1. So like we start from 1, add 1, add 1, add 1. Yeah.
Thanks.
Yeah. We'll learn more about ranges later as well. Hey, what's up?
I have a lab today,
Yeah.
but I can't go to because I have